So for this next section, we're looking at limits. And limits are really important when we start talking about actual calculus concepts. A limit, and we'll do formal definitions later, but a limit just means if I get really, really, really close to some value, I don't have to actually touch that value for x, is it going to a specific y value? So sometimes it does, and sometimes it doesn't. What we're going to do is look at things coming from both the left and the right of a particular value, and then see what's going on with it. So the first way to look at them really is tables, and then we'll also graphically look at some things. But looking at a table, I can evaluate this thing and see what values it's going towards, and then we're going to answer these questions down the bottom. But first I want to fill in my table. Now, looking at this, I see that it's factorable, so I'm going to try and cheat a little bit and simplify it. So when I plug in these values, it's going to be a lot easier to evaluate them. So x squared minus x minus 6 factors to x minus 3 times x plus 2. And then you could see these factors cancel out. Now we know 3 is not in our domain, because I'm not allowed to have division by 0, but that's okay. I'm going to be looking at the limit as it goes 3 from the left and the right, but really all I have to do is plug it into x plus 2, because these values just simplified away. So when you plug in 2.9, you get 2.9 plus 2, so I get 4.9. When I plug in 2.99, I get 4.99. And then 4.999. Remember, I'm just taking that number and adding it to 2. And then 4.9999. And then when I add 2 to this, I get 5.0001. 5.001. 5.01. And 5.1. Now, this superscript, the negative, means I'm approaching from the left side. So as I get closer and closer to 3 from the left side, what value am I going towards? Well, this is almost 5, right? So we just say we're approaching 5. If I approach it from the right side, so that superscript plus sign means approaching it from the right side, well, I see that that's also 5. So therefore, the limit as x approaches 3, because the left approach and the right approach were exactly the same, is 5. If you were to graph this, I would have to have a hole at 3, 5. But really, it's just x plus 2. Because of the way that it simplifies out. All right, B, we have x minus 3 over, absolute value of x minus 3 over x minus 3. So, again, I'm just going to do the same thing. I'm going to plug this in and see how it simplifies. Now, I can't factor away like I did the first one, but what happens when I plug in 2.9? So 2.9 minus 3 gives me a negative 0.1, but you're taking the absolute value of that, so it would be 0.1, and then down the bottom when I plug in 2.9 I get negative 0.1, so that simplifies to a negative 1. When I plug in 2.99 I get 2.99 minus 3 is negative 0.01, but the absolute value would give me a positive 0.01 over negative 0.01. So that again, I get a negative 1. 2.999, I'm going to get negative 0.001 in the absolute value over the positive. So I'm just going to get the same number on the top and the bottom, except the top's always positive and the bottom's giving me negative values. Now, 3.0001, when I plug it here, I get 3.0001 minus 3, which is 0.0001. And then down the bottom, I get the same thing, 0.0001. So anything over itself is equal to 1. And I'm going to get that for all of those. So as I approach it from the left side, what values am I going to? Well, those are all -1. As I approach it from the right side, those values are all 1. So because it's different approaching it from the left side and the right side, this limit does not exist. And that's what the graph would look like. So I'm going to 2 completely different values, so therefore the limit does not exist. Part C, I have 1 over x squared, and I want to evaluate that. And I'm looking at the limit this time as it approaches 0, which makes sense, right? Because 0 is not in this domain, so I want to know what's happening around 0. So I'm going to do approaching from the left and approaching from the right and see what happens with those. So when you plug in -0.1, you get -1 over -0.1 squared. Sorry, I forgot to do these all out. So that's 1 over 0.01. And then if you flip it, just divide that out, 1 divided by 0.01, you get 100. When you put in -0.01, square that, and then take the reciprocal again, you get 10,000. And then -0.001, square that and flip it. You end up with 1,000,000. And then 0.0001 squared, and you flip that, and you get 1, 2, 3, 4, 5, 6, 7, 8. I think it's 10. I could be wrong. This calculator didn't put it in scientific notation for me. And then on the other side, so what is happening to these numbers? 100, 10,000, 1,000,000. Like these are just shooting up to infinity. So on the other side, I want to do the same thing. When you plug in 0.0001, you're going to get the same thing as here because you're squaring it and then it's 1 divided by that. So I'm going to, hopefully that's right. And then when you plug in 0.001, it's going to be the same thing to here. And 0.01, and then 0.1 would give us 100. So as I'm approaching 0 from the left, this thing is getting bigger and bigger and bigger. It's not leveling off to some number, right? It's being multiplied. So this thing is going to infinity. As I approach it from the right, it's also going to infinity. So technically, it's do not exist, but if we know what that behavior is, we want to say what's happening to it. So even though it does not exist and the fact that it doesn't go to a real number, but it is going to infinity, so when we go to look at graphing functions, we're going to want to know what that's about, and we want to state that it actually goes to infinity.